Hello, my name is Mohan Dodda,
And my name is Reagan Khan.
and this is knowledge graph construction from stories. So why do we want to do this? We want to generate stories that are realistic and have coherent and interesting plots. We know that language models are good for generating text, but are they good for generating stories? For generating stories, we need to have a lot of information, guide our stories, and enforce consistency. Thus, we try to use a knowledge graph for this and help with the story generation process. And this knowledge graph captures the state of our story. We can use this state as a particular event and reinforce structure to better able to generate the next plot point. So how are our knowledge graphs structured? So we have nodes and edges. The nodes are subjects and objects of sentences in our story. And edges are relations within our story. So the first main part is get our subject and object and annotation process. So for this, we just use a standard POS tagger to get the subject and object of the words. And this is standard across all the different frameworks that we use. But the main part is relations, and there's a lot of different frameworks for extracting relations.
The first method for relation extraction uses VerbNet. In step 1, the sentence is labeled with POS, where each word receives a part of speech tag. In this example, the words Caesar and Brutus are labeled as nouns. Then in step 2, each verb in the sentence is looked up in VerbNet and associated verb frames are obtained. In each frame, a list of syntax and corresponding semantics are returned. Each have both POS tags. Finally, the VerbNet syntax POS are matched to POS tags for the sentence. In step 3, valid matches will trigger semantic retrieval, which uses the POS tags to match entities in the sentence to semantics. These semantics form the final relations here.
So on top of VerbNet, we use two other relation frameworks, Spacey and Core NLP's OpenIE. For both of these relation frameworks, we basically use the main verb/verb phrase in the sentence as the relation. So for example, John completed the task. John is the subject and task is the object using the previous POS tagger. Yeah, but with the same POS tagging framework, we get completed as the verb and we say that is the relation. And then Core NLP expands upon this and gets the verb and verb phrases as different relations and also looks at different clauses within the sentences and gets different relations from that.
The system runs all three aforementioned methods and takes the union of all outputs. Then a semantic duplicate filter is applied where semantically similar relations are filtered out. We employ word-to-vec embedding to determine similarity. Here, a full knowledge graph extracted from a short story with the filtering turned off is shown. Next, we have the same story but filtering is turned on. Notice that many semantically similar edges are removed from the graph. Now we'll show an example. Given a story, the system will go through sentence by sentence and extract relations using VerbNet, OpenIE, and Spacey. Each relation is a subject relation object tuple, so the system can build a graph using relations as edges. During graph construction, duplicate relations are removed by leveraging word-to-vec word embeddings. Specifically, relations with word-to-vec similarity greater than 0.1 are considered duplicates and are filtered out.
So for part 2, we want to focus on the story generation process using a language model. So how we want it to work is we just prompt the language model to generate stories and have it generate X amount of candidate stories. And then we use the knowledge graph from before as the ground truth. And from this, we see which candidate story matches best with our ground truth knowledge graph and have that be the candidate story. Additionally, we want to look at graph transformers. So this is a language model that utilizes our knowledge graph together to generate the story.
Thanks for watching.